So let us try to understand the question step by step. The question says that a uniform rod of mass m is suspended horizontally from two vertical strings, and if the right string gets snapped, find the tension in the left string at that instant. So as soon as I cut this right string, the position, the situation will be something like this. This will be the rod and this will be the string, right? So we have done a similar type of questions where that string was vertical, but here the problem is the string is making certain angle with vertical, and you can very
String itself will
easily,
move, no?
yes, you can very easily understand that when I release this, for all the time the string cannot remain at this position, right? So after some time the string will also move, and how the string at the connect the point that the string connects with that rod, how this point is moving, that you can say that the point must be moving in a circular path. Yes or no? Because this length is a constant, so about this point this will move in a circular path.
Yes, sir.
So at this particular instant when I have cut this right string, I cannot say that the acceleration of this point is completely zero, right? That
Yes,
I
sir.
cannot
Yes,
say.
sir.
But what I can say about the acceleration of this point, let us try to understand, discuss the motion of this point, acceleration of this point rather. What can I say about the acceleration of this point? I am sure that it will have some acceleration, but in which direction it will have acceleration?
So I hope it's tangential.
It's a tangential acceleration, yes. So why that acceleration is tangential? Basically in circular path, we have seen that both the accelerations are possible, tangential as well as normal,
Here it
right?
is released from rest.
Yes, as it is released from rest, so the acceleration along the string, which is considered to be the normal, is zero, right? An is zero. You can assume that an along this direction is zero, but tangential acceleration may be there. I do not know what is the value of it, but it must be tangent to the path, right? I think it is clear to all of us. Now I will
Yes, sir.
talk about this point, which is the center of mass, and I can say that the forces on this rod are these two only. One force is one force is along
It's
this,
tension and mg.
yes, along this tension. One is this tension T. Another is the weight of the rod passing through this point. Now, can I take the torque about this point A, or should I take torque about
Yes, sir. It
point
will be
C?
mg L by 2.
About point A or C? Which point I will choose?
C.
Yes. Why I will choose C point?
Oh, sir. So no
Sir, it is
problem of pseudo forces. No problem of
Yes.
pseudo forces.
If you take torque about C, there is no problem of pseudo force as you told. But if you take torque about A, then you have to consider the torque of pseudo force. And here in this case, I do not know the acceleration, so I'm not aware about the
Okay,
actual
sir.
force, that is pseudo force. So definitely I will take torque about C. Right? Torque about C is equal to IC alpha. That equation I can write. So what is the torque about point C? If this angle is theta, let us assume,
Which
and
angle
this
have you
tension
considered?
is T, about point
That is
C.
given to that one. That angle.
Yes, that angle is given theta.
Hmm.
So what is torque about point C?
It's mg L by 2. Oh,
Torque
sorry.
about point
T
C.
cos theta.
T cos theta into L by 2.
L by 2.
That should be equal to IC. What is IC?
Mn square by 12.
ml square by 12 alpha, I alpha. Yes. So I can say that T cos theta is equal to ml by 6 alpha. First equation I can write like this.
Sir, I have a question, sir.
Yes.
Hmm. Sir, you have taken that t cos theta, it's okay, L by 2, ml square by 12 alpha. Sir, I am saying that, sir, if I think like this, that the string is also performing rotational motion about its pivot, and the
Hmm.
means a rod is also performing rotational motion. So how can I understand the means rod's the moment of inertia about that point?
I'm
না আমি
taking
বলছি যে
torque. I'm taking torque about that point C. I'm not taking torque about this point. About
না
this
আমি বলছি
point,
যে সি নিজেও তো নামছে না, না ওটা উইথ
huh.
রেসপেক্ট টু সিও।
Yes, C is also moving. It has an acceleration. I know that C has an acceleration. But whatever is the acceleration of point C, the pseudo force will pass through itself. So I don't have to take the torque of pseudo force. Only torque I will take of the tension.
ওকে স্যার।
Now this is the torque equation, right? But I have to also write a force equation. So what force equation I can write? If I assume that acceleration of center of mass here, acceleration of center of mass is coming downward as well as in this direction. Can I say acceleration of center of mass will be in both the direction, vertical
Yes,
as
you
well
can
as
say.
Yes
horizontal?
sir, yes sir.
Because there are both the forces now present here, right? So what are the forces in vertical direction? What equation I should write in vertical direction?
So it should be mg minus t cos theta is equal to ma v.
Mg minus t cos theta is equal to MAV,
mfv.
right? And what is the equation along this horizontal line?
Along the horizontal line, it is t sine alpha. Sorry, t sine theta equal to mah.
H.
MAH, yes. So these are the two equations that I can find. Now how many unknowns are there? Let us calculate. T is
T is
unknown,
unknown.
alpha is unknown,
Alpha.
AV and AH are unknown. So four unknowns are there, three equations we have. So one extra equation which will what will give us
Constant.
constant equation will give us another extra equation, right? And here it is important to understand the constant. Can you tell me what is the constant logic that I will apply here?
Sir, AN is equal to 0.
An is equal to 0. Good. Acceleration of the point A along this direction is 0. So whenever I am trying to find acceleration of point A, I will first find acceleration of point A with respect to center of mass. Then I will find
Say n
acceleration.
is equal to 0. Can you repeat from there?
Yes, I am saying that acceleration of A along this normal direction is 0. So how
Okay.
do I find that acceleration of A with respect to ground? These accelerations are with respect to ground, not with respect to any other point. First, I will draw the acceleration of point A with respect to center of mass. Then I will add with that acceleration these two accelerations of center of mass. Then I can say that this is the resultant acceleration of A, right? What I will say?
Sir, means at first we will calculate the acceleration of A with respect to center of mass.
Yes,
Then perform vector addition of the acceleration of center of mass to get that with respect to ground.
yes, good.
Then
So
along that direction we'll make it 0.
we'll make it 0. Good. So first, tell me what is the acceleration with respect to center of mass above of that point A? How do I find it? With respect to center of mass, if I want to find the acceleration of point A. What is acceleration of point A with respect to center of mass? Can you tell me
So
that?
it's performing a circular motion.
Yes, good.
And sir, I'm saying, sir, the acceleration is R alpha then.
R alpha, yes. In which direction R alpha is there?
So it is in
What is the direction of alpha? Can you tell me? Clockwise or anti-clockwise?
Will it be vertically upward?
Yes. What is the direction of alpha here? Alpha is
Clockwise.
the clockwise direction. Yes. So what is R alpha? The direction of R alpha is definitely vertically upward direction, right? Vertically upward is R alpha. So this is the acceleration of point A with respect to center of mass, which is L by 2 alpha. Acceleration of A with respect to center of mass. There is no normal acceleration because it has no omega.
No initial. Huh?
Yes. Now I will add with this acceleration two more accelerations that are of center of mass. What are those?
AH and AB.
AH and AV. Yes. I will add AH and AV with this acceleration. This is AH, and this is AV. So can I say acceleration of point A is the vector sum of these three accelerations?
Yes, sir.
You can say.
AH and AV. Now, out of these three accelerations, I can say that component of all these three, if I added them, then
They will nullify each other.
yes, there will be zero here along this line where this angle is theta, right? That should give me a constant equation. Can you tell me what equation then I write?
Sir, that will be L by 2 into alpha into cos theta plus AH into sin theta is equal to
Yes,
AV into cos theta.
good. Is equal to AV cos theta. Have we got this, everyone?
Yes, sir.
Yes, sir.
Now I have to find the tension. So I will replace each and every quantity here in terms of tension. Look, first I will replace L alpha by 2 cos theta. Now L alpha by 2, I think it is 3t cos theta by m, right?
Yes, sir. Yes, sir.
3t cos theta by m. So that will be cos square theta by m. Plus AH. AH is t sin theta by m. So it is t sin square theta by m. Plus AV
AV
cos
cos theta.
AV is equal to g minus t by m cos theta. G cos theta minus t by m cos theta.
Cos square theta.
T by m cos square theta. Now if I multiply with m and I can bring it here, so it is 4t cos square theta, 4t cos square theta plus t sin square theta, right? That is equal to mg cos theta, yes or no?
Plus t sin square theta equal to mg cos theta. Yes, sir.
So the value of tension that I will get from there is mg cos theta divided by 4 cos square theta plus sin square theta is 1 plus 3 cos square theta.
So wait, sir, mg cos theta divided by 4 cos square theta plus sin square theta.
Yes, so that can be written as 3 cos square theta plus cos square theta plus sin square theta. So it is
Yes,
1
sir.
plus 3
1
cos square
plus
theta.
3 cos square theta.
Now we can calculate what is your answer. Cos 37 degree, I think it is 4 by 5
Yes, sir.
divided by 1 plus 3 into 16 by 25, right? So it is 20 mg divided by 48 plus 25 is 73. That is the answer of this question. So let me solve this question first.
Sir, one more rolling
Yes,
was done at the end of the class.
end of the class.
Tell me how to find the acceleration, and I'm getting that.
I could not hear you, but you just try to see the solution. What we can do here. Suppose this is the disk, the bigger disk I am talking about. This is the bigger disk, and suppose this is the smaller disk, right? Smaller disk.
So groove should be a part of the disk, no?
Yes, yes. Part of the disk, smaller one. Suppose here, like this, and lies the string, right? There lies the string. Now, if I say that the angular velocity of this is omega and center of mass is moving with some velocity vc, then for this point to be in pure rolling, the first condition I can easily write is vc
There has
equal
to be
to
friction.
r omega. Yes, there is some friction definitely. But can I write vc equal to r omega, this expression?
Yes, sir.
Yes, sir. From
Yes.
pure rolling.
Yes, pure rolling condition is only I have written. Now, what about the acceleration velocity of this point that is touching the smaller disk? Velocity of this point has two components. One is Vc, another is small r omega like this.
So please wait. Sir.
Yes, sir.
Yes, omega will be same throughout.
Yes,
Sir,
it's
how
a
about
rigid
the r
body.
omega? I couldn't get that.
This is r. So about this point, it is also rotating with the same omega. It is a rigid body, so omega must be same everywhere.
Sir, then what is backward?
Yes.
Sir, then why is it backward?
Backward, yes, its omega is only I have taken clockwise.
Oh, yes, sir, I get it, sir. Yes, sir.
Omega is clockwise. So if I talk about this point P, right, then velocity of this point has these two components. Can I write what is the, by in constant equation, we have to find the velocity along the string,
Hmm.
right? So along the string, what is the velocity of this point P? Can I write it is Vc cos theta minus r omega, or r omega minus Vc cos theta?
So you write Vc cos theta minus r omega, sir. I think that will be better.
But that will be plus or minus.
Sir, I am saying that Vc cos theta minus r omega will be better because from constant it will be equal to V.
No. Do you remember the constant equation?
Yes, sir.
What was the constant equation? If this is V,
এটা বাইরে যাচ্ছে তাহলে ওই দিক থেকে ভিতরে আসবে না?
so at this point, if some velocity is inward the string, what I take that velocity, plus or minus? Minus. And if the velocity is away from the string, we take it plus.
Yes, that I remember.
Yes, sir.
So
Right?
from there only I am saying Vc cos theta
Yes.
minus r omega should be equal to V, no?
Okay, let us try to write it. So if it is outward positive, I will take r omega minus Vc cos theta plus V is equal to 0, yes or no?
Yes, sir. We can write.
Right? So I can write, yes, Vc cos theta minus r omega is equal to V. You can definitely write it. Now what is omega here? I have to calculate the angular velocity, and Vc I can replace by r omega, capital R omega. Yes or no?
R omega cos theta minus small r omega.
Yes. So omega is equal to V divided by capital R cos theta minus small r. That should be the answer of this question. This question says a convex surface has uniform radius 5r. A wheel of radius r is rolling without sliding on it with a constant speed v. Find acceleration of the point P which is in contact with the convex surface. Now, forget about the convex surface. Think about the wheel first. If I think about the wheel, suppose this is the wheel. Suppose this is the wheel. And if I ask you at any instant, what is the velocity of the point P? Velocity of
Zero.
this point P. It is 0.
With respect to surface, yes, 0.
But with respect to ground also it is 0 because this convex surface is not moving.
Yes, it's stationary.
Right? So velocity of this point is 0. And I can say that velocity of the center of mass is V given in your question. Right? But what is the acceleration of this center of mass? Is it 0?
Sir, is it, sir, I'm saying, sir, is it V square by R into the center of the convex
Yes.
surface?
Acceleration of this
V
C
square by 6R, sorry.
is towards this point V square by 6R,
Yes, sir.
because the center of mass, center of this wheel is rotating in a circular path of radius 6R. Yes or no?
Yes, sir.
Now if I ask you what is the acceleration of point P, acceleration of P with respect to C, that I first calculate. With respect to C, what is the acceleration of point P?
So with respect to C, it is, say, it is omega square R towards the top.
Square by R, same way.
Yes, it is omega square small r, or yes, omega square r towards the center. Now what is this omega?
So omega.
Yes, what is the value of this omega?
Omega,
This
Omega
angular
is
velocity with the disk is
V by
rotating.
R.
It's like
It's
R
V
omega.
by R, no. It's
I
not,
mean-
it's V by R, no, V by R.
Yes.
V by
As the point P has to be at rest, velocity of this point P has to be at rest. So that means V equal to r omega. That should always happen.
So this one
Yes, sir.
Yes
so
or
this
no?
one won't say, sir.
Yes, sir.
Velocity of point P is 0. That is why we write V equal to r omega. With respect to C, the
Yes, sir,
velocity is
that
r omega.
basic concept.
Yes. So V equal to r omega. And I can say this omega square r is V square by r then.
Yes, sir.
Yes or no? So what is acceleration of P with respect
With
to
respect
ground?
to, we'll add vectorially that acceleration of center of mass.
Yes. In that case, it will be V squared by R in upward direction and V squared by 6R in downward direction.
Yes, sir.
Right? So net resultant acceleration is 5
5 V square by 6R.
by 6R in upward direction. Upward means towards the center.
Towards the center of the wheel.
Yes. That is the acceleration of this point P. Have you got it? Even if we have an alpha, suppose we have an alpha, we have some alpha, along with this omega we have an alpha, then the acceleration of center of mass is something, suppose AC. Then what is the acceleration of this point P with respect to center of mass? This diagram, what I will write now,
With respect to center of mass, though.
with respect to C, what is the acceleration of point P?
See, it will remain omega square R
Omega
only
square R.
if it's pure rolling.
Omega square R, but is there no tangential acceleration? Because about CP is rotating in a circle with the same alpha.
Sir?
Yes.
Sir, please repeat.
Will there be no tangential acceleration of P?
So then it should be slipping then.
With respect to C, I am talking about. With respect to C, it must have an R alpha.
Mm,
C is the center, P is moving with circle with alpha and omega. If you are taking omega square R, why you are not taking R alpha? That is my question. P is rotating in a circle with respect to C of radius R. It has omega and alpha. So what should be the two accelerations of the point P with respect to C?
yes, sir. It's omega square r and r alpha with respect to c. Yes, sir.
Yes. But with respect to ground, what should I write?
So then we have to add AC also.
We have to add AC also. Omega square R is there. Acceleration of C is also there in this direction. R alpha is also there in this direction. And V square by 6R is also there in this direction.
Sir,
Acceleration of C. Now acceleration of C is not only in this direction,
got it, sir.
right? Acceleration of C will also be in this direction, normal direction, which is omega
Yes,
square
sir.
R or V square by R. And as it is not in pure, as it is in pure rolling motion, so with
It is slide
respect to
AC equal
ground,
to r alpha.
yes, AC equal to R alpha. So you can neglect this horizontal component of acceleration. So your answer will be the same, V square by 5, V square by 6R. Same answer will be there. It has no effect on the acceleration of the disk.
Yes, sir.
Alright. Have we done this question?
So show once. Yes, sir. This one done.
This was done. A long string is wrapped around a disk. One end is suspended from ceiling, and when the release, the disk comes down without slipping.
This one done.
This one,
Yes, this one is not done. Sir,
yes.
so
So what
let's
is
see
the answer of this question?
So will it be G by 2?
No, I don't think it's G by 2. Anyone else got the answer of this question? Okay. It's a very similar type of question to the previous one. Now there are two disks, right? One is solid cylinder, another is hollow cylinder. There are two cylinders. So let me draw them one by one. So first this yellow color cylinder, suppose this is the yellow color cylinder, and then this is a hollow cylinder, right? A hollow cylinder is there. Suppose this is the hollow cylinder. If I talk about the forces on the cylinders, then on the first cylinder, what are the forces? Can you tell me? What are the forces on the first cylinder?
So it is the hinge force, we can say that from the ceiling.
Yes, hinge force is there from the ceiling, weight is there,
Then mg is there and tension is
and
there.
tension is there. Good. And for it,
Yeah, for it mg and tension only.
the same tension is there and mg is there.
Yes, sir.
So here can I say that hinge reaction, suppose anything we can assume mg is weight, tension is there, tension is also there, and the same mg is acting there. Now suppose it rolls with angular acceleration. Now it is a pure rotation, yes or no? This first cylinder, is this a
Rolls
pure?
with angular acceleration. Yes, sir. It's pure rotation.
It's a pure rotation about this hinge point, yes or no?
Yes, sir.
So if it is a pure rotation, let us assume it to be angular acceleration alpha 1, and let us assume this angular acceleration to be alpha 2.
Yes, sir. I have a problem here, sir.
Yes.
So in this means this alpha 1 and alpha 2 need not always be same. So.
Yes, need not always be same.
Hmm.
Without
Okay, sir.
calculation,
I was thinking
I
that
cannot
if it
say.
is same.
Yes, I cannot say without calculation alpha 1, alpha 2 are same or not. So what equation I can write
Okay.
for the first disk? About which point I should take torque for
About
this one?
center of mass, that is only the pivot point.
About center of mass C1 I can take torque. So torque about C1. If I take, what is the torque?
Talk about C1. That's TR.
T into R. Can I write that is equal to I alpha? And what is I?
I is mr square by that is mr square into, I think, alpha. Is it solid or hollow?
The above one, it is a solid one.
Okay, sir. Then it is mr square by 2 into alpha.
And for this lower cylinder,
For it is rolling motion.
can I take torque about C2? Torque about center of mass anytime you can take without any thinking. Torque about center of mass is always correct.
Hmm. So then it will be TR is equal to mr square into alpha 2.
Mr square into alpha 2. This is alpha 1 and alpha 2. Can I get a relation between alpha 1 and alpha 2
Yes,
from this?
sir. Alpha 1 is, I think, 2 times alpha 2.
Yes. So that equation I can use. Yes or no?
Yes, sir. Yes, sir.
Now what else I can write? Uh, this torque equation I have already written. Let us assume the acceleration of the center of mass for this lower cylinder is A.
Hmm.
Right? So what equation I can write as force?
mg minus t is equal to mm.
Mg minus T is equal to Ma. That is the second equation. Right? And acceleration of it is 0, so I don't have to write any force equation here. Acceleration of this is 0. Now how many unknowns are there? Let us calculate.
Alpha 1, alpha 2, and t.
And A.
Bapre. A
Four
also.
unknowns are there, but three equations we have got. Yes
Oh,
or
yes,
no?
there are two. No. Then one constant equation.
One constant equation I should write. And what is that constant equation? Can you tell me here?
So that.
What is the logic for constraint here?
So will it be R alpha 1 is equals to A?
It's not R alpha 1 is equal to A. Okay, what is R alpha 1? Let us first assume, try to understand that. What is R alpha 1? If you think about this string that connects the two cylinders, what is the acceleration of this topmost point? What is the acceleration of this point?
So that will be R alpha 1.
Is it R alpha 1 downward?
Yes, sir.
And what is acceleration of this bottommost point? Now think about
So
this cylinder. What is acceleration of this bottommost point?
it is R alpha 2.
Is it R alpha 2? No.
Sorry, sir. So please wait, sir. So it is, sir, please. So R alpha mg minus, sorry, A minus R alpha 2.
Yes. With respect to center of mass C2, it is upward R alpha 2.
Yes.
And with respect to ground, I have to also add acceleration of A with that.
Yes, this one only.
Right? So now I can write a constant on that string.
We are getting R into alpha 1 plus alpha 2 equal to A.
Yes. So I can write minus R alpha 1 minus R alpha 2 plus A equal to 0. Can I write it? Right? So
R
I
into
can
alpha 1
write
plus alpha 2 equal
R
to A.
into alpha 1 plus alpha 2. R alpha 1 plus R alpha 2 is equal to A. That is your fourth equation. Basically, if you take it, it is 1 and 2. Right? And then it is your third equation and it should be your fourth equation. Now can we solve it?
Yes, sir. Now we have to just solve it. We have to
Yes.
find A. Okay, sir.
Try to solve it. Just you can solve it, these equations. Now it's very easy.
So solving, sir. Please wait. So will it be 3G by 4?
Yes, the
Okay.
answer is 3G by 4. If you solve, the answer will come to be 3G by 4. Have I given this question as your homework?
Yes, sir. Sir, I'm saying trying the answers once. So
Yes.
will the sir, I'm saying the answers. So will the first answer be 2G by 9?
It may be. It may be. I don't remember.
Sir, second answer G by 9.
Yes, I think answer is something like that only.
And third answer I got tension 4mg by 9.
Two tensions. The tensions are two.
The
Not
tensions are same, no sir.
no, the tensions here will not be the same.
Sir, it is the same string, no?
Same string, yes. But again, the tensions are different. Look,
So I calculated and I think I proved also tensions are same.
look, if the tensions are same, then there is a basic problem on rotation. Can you tell me? Can anyone tell me what is the problem if tension is the same?
So both effect will be nullified.
Yes. For this disk, if you think about this disk, right, that pulley, that lower pulley, if you think about this lower pulley, and if the tensions in both the sides same, then what is the torque about the center of mass?
It's
Will
0.
it be zero or not? If the torque is zero, then who is going to rotate it? Understood? If torque is zero, then there is no rotation possible. So that is why, and here you cannot take tension to be same. Even if the string is same, string is massless, then also I am saying tensions are not same. Can you tell me why? Anyone else?
Yes, sir. As you said, it will not rotate.
No, it is rotating. The lower pulley is rotating. It's in pure rolling motion.
Yes, then
But
if
yes,
it is your voice.
yes. Can you hear me? Am I audible to you
Yes,
clearly?
Yes, sir.
Yes. Now my
Yes, sir,
question
you are
is,
audible.
my question is that I know that now the tensions should be different, right? In order to roll it, tension should be different. But what is the reason behind that difference of the tension? As I
So
have
Like I
the
said,
rolling torque is needed, but if
so
the tensions are equal,
for rolling,
No,
there
that-
should be a net
force equals to
torque.
zero.
There
no,
should be a net
that
torque.
that I understand that if the tensions is not equal, that I can understand that it cannot rotate. But what is the reason behind that difference of the tension?
So here the tensions are both in the same direction. Is that
No.
Sir,
I
please
have
wait, sir.
mentioned.
So please, sir, once, sir, once.
Yes, yes.
Please wait, sir. Lossless fixed
In laws
only
of
and
motion, we have said that if the tension is string is massless and
with friction.
yes, friction is the reason here.
Oh,
Even if
here
the
it's rolling,
string,
no.
yes, even if the string is massless, there is a friction between the disk and the string. There must be a friction, otherwise the disk cannot rotate, cannot roll,
yes, sir.
right?
Superb, sir, superb.
So as
Or
there is
else
a
it will behave
friction,
like a normal small like
Yes, it will not roll
small
only.
yes, it will slide only, slip. It can slip without friction, but as there is friction, so I cannot take the tensions to be the same. So let us assume the tensions at two sides to be T and T prime, right? Tensions here is T.
Take
This
T1,
is
T2, sir.
Okay, T1, T2, no problem. So it is T1 and T2, and this is mg, right? The block has mass 2m, and the disk has mass m, radius r. And another free body diagram we can draw for the block. For the block,
So I hope that will be T1 at least, or will that also change?
yes, that is T1. Why? Because this pulley is massless, frictionless.
And this one is not rotating also, this
Yes.
pulley.
If it is massless, look, the two tensions now has to be same. Can you tell me why? If this is massless, now the two tensions has to be same. Even if there is friction or anything, now the two tensions has to be same. If it is massless, the two tensions has to be the same.
So because acceleration is zero.
If it is massless, then even if it has an angular acceleration, even if it has angular acceleration or not, but in this case, what is the torque? Tau is equal to I into alpha. Now, moment of inertia is what?
Okay.
Moment of inertia is zero or not?
Zero. So torque will always
Torque
be zero about
will
any point.
always be zero. That is why it is always the net torque is zero here. The tension should be the same.
So net torque zero means no rolling, hence tensions are equal.
Yes. So I can say that this 2m block, we are pulling this 2m block with the tension T1. Now the tension is same as that of this one, right? This is an ideal pulley, you can assume. This is an ideal pulley. So this is T1, this is 2m. This is no friction.
Sir, inaudible for me. Right now, I cannot hear anything actually.
I can hear you. Why you can't hear me? Is there a network problem at your end, I think? চেক করো তোমার বিএসএনএল এর কানেকশন চেঞ্জ করো আগে তুমি রোজই একই প্রবলেম বলছো টেক এয়ারটেল or Vodafone or now Vodafone is VI or anything else. Geo, if I know, I don't know whether Geo works or not. At my place, Geo does not work, but Airtel works perfectly. Take Airtel connection. Is that the free body diagrams okay, everyone?
Yes, sir.
Yes. Now, if I take this acceleration to be A and acceleration of the center of mass of the disk to be B, what equations I am going to write? Tell me.
So you write the constant first only.
Okay, constant one.
Minus T1 minus T2 is equal to MB.
Mg minus, okay. Let us first write the easy equations.
Okay, sir.
Mg minus T1 minus T2 is equal to Mb. No problem in it. T1 is equal to 2Ma. No problem in this.
No, sir, no problem.
How many unknowns?
Sir, it's A, B,
There are four of them.
T1, T2.
Four unknowns are there. Right? Four unknowns are there. I
Sir, I
need
will.
another equation. What equation I will get?
Sir, I hope it is the torque equation. Torque equation.
Torque equation. Yes, torque equation. Can you tell me a suitable point about which I will take torque?
So center of mass of that disk.
About C is the
Center
I mean
of
that's
center of mass of the disk.
Or about an in.
yes, sir.
But I have another easy way to solve it. Can I take torque about this point A?
Okay, sir, it's rolling.
As it is rolling and it is connected with top at rest. So what is the acceleration of this point A? It should be 0 or not.
So either A or B, I think anyone you can take them.
But point
Sir,
B,
not about B because that is
Yes.
not fixed.
point B is coming down. Point B is coming down with some acceleration. Can you see that?
Sir,
This is string. This is string. I will draw the constant motion of this string. What is the acceleration of this point of the string?
it's A.
So how can you say that this point is at rest?
Okay, sir, I cannot say.
Now is this point also coming with acceleration A? Yes or no?
Yes, it should come. Hmm.
This is
Yes,
the
sir.
this is the first string. But if you talk about the second part, second vertical string, if you draw it,
Sir, is it A only or something greater than A at the point B?
how it can be
And then
greater
you
than
said
A?
it's A.
Otherwise, this constant equation will not hold true.
Sir, but the length is increasing of that part of the string.
No. The length may increase or decrease, that does not matter. But if you think about this, look, suppose you have marked one red dot here and you have marked one black dot here. Is the distance between red dot and black dot increasing, decreasing, or constant?
No, sir, nothing.
It will remain constant or not?
Which one, sir? Where is the red dot?
Yes, sir.
If you mark a red dot here, just at this point on the string, and if you mark a black dot here, just at the point of the on the string, will the distance between this red dot, suppose this is my red dot and this is my black dot, will the distance between red dot and black dot change or it will remain the same?
Remain the same.
Same, yes, they are on the same part on the string. So, and the length is not contracting, elongating, anything. So, the length
Sir,
becomes
sir,
same.
I have one question, sir.
Yes, tell me.
হ্যাঁ স্যার, মানে এটা আমি বলতে পারি যে ওই যে গ্রিন ডিস্কটা আছে, যে অ্যাক্সেলারেশন অফ দ্য স্ট্রিং 1, ওটা শুধু ডিস্কটাকে নামাচ্ছে তো? না।
ডিস্কটাকে নামাচ্ছে বলতে ডিস্কটা তো এমনি ওর ওয়েটের জন্য নামছে, অ্যাক্সেলারেশন নামাচ্ছে কোনো বুঝলাম না।
হ্যাঁ স্যার, ওইটা নয় স্যার, স্যার আমি বলছি যে ইজ দ্য গ্রিন ডিস্ক রোলিং অন ওয়্যার 1, string 1?
Yes, definitely. It's rolling on 1 as well as on 2. It's rolling on 1 as well as 2. You can take this example. We have done this one example earlier. Suppose this is a disc kept on a horizontal ground and you have placed one plank over it. Plank is moving in this direction with acceleration A and the disc is pure rolling. Now if I ask you, is the disc is in pure rolling on the plank as well as road or only on the road?
So it should be both.
Both. This is the same case. This is at rest but it is coming down.
Okay, sir.
Have you got
Okay,
it?
sir.
It has the same acceleration here. This point I have marked as red. This point I have marked as green, black. Same
Is the
similar
blank is going
configuration.
on it with acceleration A to?
Yes. And it must be at rest all the point.
Yes, sir, the relative.
Again, if there is any doubt, you can ask me.
Yes, sir, till now it's okay.
Everyone, have you got this one? What I'm trying to say? Yes or no?
Yes, sir.
Then what constant equation I should write? Just tell me. Okay, before constant, about this point A, can I take torque? First tell me. About this point A, can I take torque?
About point A.
A.
Yes, sir, you may then.
Yes. There is no acceleration in vertical direction of this point A.
Okay, sir.
So if I take torque about A, which one is producing torque?
That calls for mg and t1.
Mg and T1. Okay. So which one will produce larger torque? MG or
That's
T1?
mg. That's mg.
T1.
Yes. No, can you tell
T1.
me in which direction the
MG.
alpha is? Clockwise
Alpha is
or
clockwise.
anti-clockwise?
Clockwise.
Look, if alpha is clockwise,
Anti-clockwise. Anti-clockwise.
yes, if alpha is clockwise, a point is at rest, then what will be the acceleration of center of mass? Upward or downward? If alpha is clockwise?
Upward. But that is not the
Upward.
case. Will be upward.
But the pulley is going downward, so it is very easy to understand that alpha is downward. Alpha is anti-clockwise.
Sir, please wait, sir. Please wait, sir. For 1 second. Sir means.
Have
So,
you
or
got
can
it?
we say like this? Means that off point A, means if it's clockwise, the acceleration is not balanced.
If it is clockwise, okay, no problem. Let us take it clockwise. You can take it clockwise. If you do not know, you can take it
No, sir,
clockwise.
I'm saying, means can I say like this, that if I take it means clockwise, then
Yes.
acceleration at point A is not 0.
You can also take it. Yes. If you say that acceleration of point C is downward, and if it is clockwise, then with respect to C it is also downward. So how this acceleration of A will be 0? Yes or no?
Yes, sir, I am saying that only, sir.
Yes, that also you can say, no problem.
Sir, and what did you say, sir? Means
You are talking about acceleration A with respect to C. I was talking about acceleration of C with respect to A.
okay, sir.
Okay. So if I take torque about A, what should I write? Mg into R minus T1 into 2R. Yes or no?
Mg into R minus T1 into 2R. Yes, sir.
That should be equal to what?
So that should be equal to I alpha.
I know that, but what is I?
Oh, sir, that will be mr square by 2.
Is it mr square by 2? Everyone agrees with that?
Sir, 3 mr square by 2.
3 by 2 mr square. Right? Because I am talking about this
Yes, you're taking about A.
into alpha. Look, this torque equation is important to understand. Is it okay?
Yes, sir.
Yes, sir.
Now I can find another constant equation. What constant equation I can write? Can you tell me?
Sir, A is equal to.
A is equal
You
to?
can write, sir.
A is equal to.
And yes, what is the relation of A and B? You can tell me. What is?
So please wait, sir. I'm saying A. Yes, A is equal to 2B.
A is equal to 2B. Yes. How we can say that? Can I say about point A, B is coming downward with 2R alpha?
Yes, sir.
Yes.
Yes or no?
Yes, sir.
So acceleration of B is equal to 2R alpha,
With respect to A.
but A is at rest. Is it with respect to ground also?
Sir.
Yes, sir.
No, sir.
You can say that.
Yes.
No, sir. No, sir.
Why not?
Sir, because A itself has a leftward acceleration.
I am not talking about the horizontal acceleration because they will not be important here. Right? I am talking about AB is in this direction only. Vertical acceleration.
Yes, sir, it is correct then.
Right? And what about acceleration of C then? Is it R alpha only?
Yes, sir. You can say that.
That is
The
equal
acceleration
to.
of C is. Yes, sir.
And can I say acceleration of B is equal to A?
Yes, sir, you may.
Right? So I can say that R alpha equal to B R alpha equal to B is equal to A by 2. That is my
So we could have
concept.
done it through that constant diagram also. You draw all the time.
Yes, yes. That also you can do. So are these equations correct? 1, 2, 3, 4. Then you can solve this question.
Yes. So I am saying that in the constant diagram you draw with the strings, the acceleration should be the center of mass acceleration. So,
Yes, 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 yes. Constant, when we draw in that Newton's laws of motion, the accelerations were center of mass acceleration.
okay, sir. What do we have to find anyway? A1 and
We can find now A, B and tensions. We can find from 4 equations, 4 unknowns are there. I can first eliminate alpha, I think. Alpha is not needed.
Background sound.
Mg minus 2T1 is equal to 3 by 2 Mr alpha M into B or M into A by 2. M into A by 2. Let it be M into A by 2. So 3Ma by 4. T1 is equal to 2Ma. So Mg minus 4Ma is equal to 3Ma by 4.
T1 is what, sir?
T1 is equal to 2Ma that I have written here. So 2T1 is equal to 4Ma.
19 mm by 4 is equal to mg, I think.
Yes. So 16 plus 3, 19 A by 4 is equal to G. So A is equal to 4G by 19. Yes, 19. Someone was talking about 9, I think. But it will
Yes,
be
sir.
19,
I
yes.
did everything as 9.
But it will be 4G by 19. And acceleration of B will be 2G by 19 then? Yes or no? Acceleration of the pulley is B, which is A by 2, that is 2G by 19. And what about the tensions? Now I can find T1 is equal to 2M into A. So 8 mg by 19. And what will be T2? Mg.
Sir.
Bolo.
Sir, can you please once again explain why AB is equal to
Why? AB equal to
A?
this one. Yes. Because this, here I have drawn. Na? This is string, you can check. This is string. Number 1 string. This number 2 string. This number 1 string, if this is moving with A, then this will also come with A because there is no slipping here. This is an ideal
Yes,
pulley
sir.
I have assumed. So if it is coming down with A, then this point must come down with A.
Yes, sir.
So what is acceleration of B? This point is only B that is connected with this pulley.
And we are finding that with respect to A and then doing 2R alpha.
With respect to yes. With respect to A, I can
Yes,
also
sir.
say
Got
it
it,
is
sir.
2R alpha. Right? So mg minus T1 is equal to 11 mg by 19 and minus 2 mg by 19 is 9 mg by 19. I think it is 9 mg by 19.
Yes, sir, it is very.
So can you please wait for 1 minute, sir?